starting again. All right. All right, do you see everything?
Mm-hmm.
Okay. All right, so as I said before, if structures, chapter 3, we're covering chapter 3. So with if structures, they're the same as in Python. They work in the same manner. The only difference is the syntax. And the syntax is not that hard to remember. The only thing that you have to know is after each Java statement, you have to put a semicolon. It's the same thing as whenever you use those statements outside of your if structure. So nothing new there. And the only difference with if structures is with Python, we had to just put a colon here at the end and then put whatever we want to execute in that if structure inside. But in Java, we have to use curly braces, and curly braces will show that all of these three statements belong to this one if structure. So in my opinion, it's more useful this way. I like Java more for decision structures than Python because it's just easier to follow. It's easier to see what's going on. You immediately know when you see the curly braces, you will immediately know that everything that's inside of the curly braces belong to this one if condition right here. And as you can see here, semicolon after each statement, after each Java statement. So semicolons and curly braces, all that you need to memorize whenever you're working with if decisions, if structures in Java. And these are the relational operators. They work the same way as in Python. They look the same, they mean the same thing. So I'm not gonna spend a lot of time on these. The PowerPoints are in your e-learning, so if you need a refresher, you can go back and see what these mean, but they're pretty self-explanatory. Now, Boolean expressions also, they work the same way. We covered them already. And what Boolean means, another refresher, that Boolean will only result in either true or false. So it will not give you a value. It will only give you either true or false. And see the expressions, they work the same way as they did in Python. So greater than, less than, greater than or equal, less than or equal to, not equal to. So same thing, and each one of these expressions will result in either true or false. Nothing else will get nothing else will be the result of these expressions. Now this is a little example for you, and the cool thing about Java is that if you only have one Java statement inside of your if structure, the curly braces are optional. So you can either put these curly braces if you want. I would recommend that you do, just to get that practice in, and just so you don't forget to put them when you actually have to put them. So I would just recommend that whenever you write your code, you put the curly braces, even though it's one statement, but just so you know, if you don't want to put them and you have only one statement, you don't have to put them. So as you can see here, if x is greater than y, then if x is greater than y, then it's going to be printed out that x is greater than y. Now, in this case, if x is equals to y, then it's going to print x is equal to y. And then if x does not equal to y, see, we have three statements right here, three Java statements. That's why we have curly braces, because if it's more than one, you put curly braces. So if x is not equal to y, then we're going to print x is not equal to y, and then we're going to assign x to y, and then we're going to print however now it is. So that's all the things it's going to do. Yeah, so the if statement, how a Java compiler looks at your if statements. Let me get my cat. All right, how your Java compiler looks at the if statement, if you have only one line, only one statement that goes to your if, even though it looks like it's two lines, your compiler will think it's just one line, because remember that a semicolon, it marks the end of a Java statement, and there's no semicolon here. So whenever your compiler will look at this, it will see if average is greater than 95, it will not see a semicolon, so it will just keep going. It's going to look at grade equals A, and then it will see the semicolon, and only then your compiler will know that this if structure is done. Like this is the end of the if structure. Now, this is also a way to do it. See, functionally, this is functionally equivalent to this line, even though everything that, the only difference in here is that we took these spaces out and we moved grade to be on the same line with our if statement. However, it's still considered, this considered the one statement and these considered one Java statement. Yeah, as I told you before, so the rule of thumb that your book is describing to you is that if you have only one statement, you should put them on the same line. However, if you have multiple statements, you have to use curly braces. However, again, I recommend that you use curly braces even if you have just one statement. So what you would do, you would put a curly brace here, then you would put your grade equals, let me show you. You would put a curly brace here, and then you would put like a curly brace at the end or on the next line, doesn't really matter. Just as long as you start using them, because you have to get used to that. You know, curly braces, we've never seen them before, never used them before. So the more you practice them, the more it's gonna get in your head that you have to do them, and then it's just gonna be an automatic movement. Every time you print, every time you type an if structure, you're gonna automatically put your curly braces. Yeah, see curly braces. So whenever your compiler sees actually curly braces, then it will know that it's going to look for the closed curly brace. And then that's going to be the end of the statement, not the semicolon. So your compiler will recognize that you want to group all of these statements together because they're inside of the curly braces. See, this will not work in Java because we are trying to do 3 statements. We're trying to execute 3 statements, and we're trying to execute them if this expression is true. However, since we don't have curly braces, only the first statement will be executed, because in this case, your computer will look for a semicolon because it does not see a curly brace anywhere. So if it doesn't see a curly brace, it assumes that you only want to execute just one statement. Again, that's why you should be using curly braces. That's why you should get in that habit of using them. Now, flags are just, it's a Boolean variable, so it can either hold true or false, and it's gonna hold that variable for you just to monitor whatever happens in your program if some condition changes to true or if some condition changes to false. And for example, here we have if average is greater than 95, then a flag called high score will be equal to true. And then we can test that condition later if high score, and what this means, we don't have to put if high score equals true, because our if condition will only execute if it is true. So you just have to put if high score. You don't have to specify which you don't have to specify if high score equals true. So you just need to put if high score, then we print that's a high score. So that's all the flag does for you. It just checks if condition is true or if condition is false. You can compare characters, and remember, I don't know if you watched the videos yet, but there's a video about characters, and char is a data type that stands for character. And in this case, we're trying to assign char C to capital A, and then we're checking if C is less than Z, then we're going to print A is less than Z, this is very confusing. I'm not sure why it has to be that confusing in the book, but basically what it does, it just tests if A comes before Z, everything that this condition is doing in the Unicode system. And remember, Unicode, from the very first lectures of PLD, Unicode is just a way to store our characters and store numbers in a binary system. So it just checks if this A comes before Z, and in Unicode, A comes before Z. That's why this would be printed A is less than Z. If else statements, they work the same way as they did in Python. The only difference is, again, in syntax is a little bit different. So again, it's very simple. So is it called outside? If this condition is true, then wear a code. If it's false, wear shorts. That's the general logic behind if else statements. And this is a nested if statement. So let me show you what it would look like actually in the code. And whenever you're trying to come up with nested if statement, you have to use the curly braces. And this is a very important part in the nested, because the nested will show you which other if statements belong to which outside if statement. So in this example, if it's cold outside, we have another two choices to make. So if it's snowing, then we would wear a parka. If it's not snowing, we would wear a jacket. But as you can see, even though this is just one statement, they're still using curly braces. They're putting this in the side of the curly braces just so it's easier to see which statements belong to which if statements. So which code statements belong to which if statements. That's all there is. So these two belong to if, and where shorts belong to else. And you can easily tell that where they belong because of the curly braces. Yeah, as I said, they're not required. If it's just one statement, they are not required. But if you don't use them, your code will just get so mushed together, and it's just going to be really hard to understand what's going on. Yeah, see, if else these two go together, then these two go together because they're the inside condition and these are the outside conditions. If else if, also another thing that Java provides to you. And what it does, it just gives you an opportunity to add more if statements, basically. So in this case, we're checking if our expression 1 is true, then something is going to happen that's here. However, if it's not true, we're not moving straight to else. We're moving to our next block of code that's called else if, that we're going to evaluate another expression. And then we're going to see if this expression is true, then we're going to do something that's inside of this statement. And then you can insert as many of these as you want. So you can do if, else if, else if, else if, else if, else if, until you want to stop. There is no limit on how many else ifs you can put. But you will only have one if, and you will only have one else. There are limits on those. So one if, one else, as many else ifs as you want in between of if and else. Yeah, so they can become really complex. You can see here, these are all just nested. So if score is less than 60, if it's false, move to the next one, move to the next one, move to the next one until the score is 100. So this is a flowchart for a very complicated if-else-if structure. Logical operators, we've covered them before, and, or, and not, if you recall those. So these are what they look like in Java. If you want to use and, in Python, you just had to type and. However, in Java it's different. You have to put these two, which mean and. Now for or, you have to put these two characters, and for not, you have to put an exclamation sign. And again, what and does, it just evaluates if one side of the expression is true and the other side of the expression is true, then the whole thing is true. Then what or does, if only one side of the expression is true, then the whole big expression is true. And then not, what not does, it just negates your whole expression. So if it's true, it's going to be false, and if it's false, it's going to be true. As you can see here, this is the AND operator, and this is how it works. This is the table for the AND operator. So if our first expression evaluates to true and second to false, then it's going to be false. And again, if we switch those, so false and true is going to evaluate to false, false and false will evaluate to false, and true will evaluate to true. Only if both sides of the expression, both of the expressions are true, only then your big expression will evaluate to true. Now with OR is different, only one expression has to be true for the big expression to evaluate to true. So in this case, you can see true, true. Now, if both are false, obviously it's going to evaluate to false. And then if both are true, it's going to evaluate to true. And not just changes your expression. True changes to false, false changes to true. Yeah, so short circuit evaluation, what it means is just it checks the first one, the first expression, and in terms of using AND, if your first expression is false, then it's not even gonna, your compiler is not even gonna look at the second expression, because there's no point, because AND needs both of those expressions to be true. That's why if the first one that it sees is false, it's not even gonna bother to check the second one. The same with OR and true. So as soon as it sees that the first expression is true, it's not even gonna check the second one, because only one is needed for it to be true. That's what it means by short circuit evaluation. Order of precedence. Here is the table for order of precedence. So which operator goes first, and what we do first, what we do second. And this table is just the same thing as an algebra, basically. The only thing that you need to know is that the not operator goes first, then all of our multiplication, division, and modulus goes, then addition and subtraction goes, and then goes less than, greater than, all of these, the Boolean operators, and then equal or not equal, then logical AND, then not, no, this is an OR, then logical OR, and then the assignment and combined assignment operators. So this is just a table. You don't have to memorize it. You just have to be familiar. And the only thing that I would recommend you memorize, do your nots first. So if you see a logical expression in front of you, do the not first. That's all I'm gonna tell you. Strings. Let's see. Scopes of variables. Scopes of variables work the same way as they did in Python. So you have to, for example, if a variable exists only inside of a method, other methods will not see it because it's called a local variable. So other methods will not know that it exists. So whenever you declare a variable inside of your method, it's going to terminate when that method ends. It will stop existing. That's all it means by variable scope. Let me see. What else? Conditional operators. Switches. True, false. Yeah, so what switch is, basically we covered a case statements for a little bit. It was just like 5 minutes of one lecture in PLD 101. The case, I've never seen anybody use cases, if I'm being honest, in the last couple of years, but all there is just case is the same thing as your if structure, and it's just a different name to it. So what case is gonna do, if something happens, the case is gonna have a certain number. Let me show you an example here. So we have a switch, and then it will take a number, some kind of number from 1 to 10. And what it's gonna do, if that number is 1, 3, 5, 7, or 9, it's gonna print odd. And if it is 2, 4, 6, 8, 10, it's gonna print even. So as you can see, it's very simple. You can just pass a number to a switch, and if that number corresponds to any of the cases, something's gonna happen, what's inside of that case. Same thing as if structures, just a little bit different way of doing it. Switch. Yeah, in Java 12 or later, which is what we're going to be using, you can use an arrow case syntax. And what it does is just if case 1, system.out.print January. If case 2, do this. If case 3, do this. So instead of using colon and indentation, you can use an arrow. That's the whole difference. This is how you would specify multiple values: 1, 2, 3, 4, 5, spring semester, 6, 7, summer semester, 8, 9, 10, 11, 12, fall semester. And again, the number is being passed right here. And then whichever number that is, your compiler will look at all of the cases and it will find the corresponding number, and then it will do whatever that case states the compiler to do. Yeah, if you have to use more than one statement, if you want your case to do something that's more than just one line, you have to do curly braces. Same thing, again, the same idea as with if statements, nothing different. The only thing that we added is a arrow. That's all there is. Let's see, the semicolon at the end of your statement. Let's see. Oh, and the last thing, the system.out.printf method, and F stands for format. So what we have now, we have just the regular print, right? We have just the one without the F. Then we have one with LN, which stands for new line. And then we're adding another one. The next one that we're adding is F, and F stands for format. And it's a very useful thing because it will help you format your strings however you want them to be. For example, this is a general idea of how you should do it. So I'll just show you an example because it's easier. As you can see here, we have system.out.printf, and then the string I worked, and then you have this %, and the letter D, and then hours. So what D stands for, it just tells your method printf that you will put in this place, you will put some value, some integer value. And as you can see here, we put a comma and then we put hours. And what does hours equal to? Hours equals 40. So what this will print, it will print I worked 40 hours. And it's a very useful function to use later on when you have a lot of variables and when you have different, for example, if you're working with decimals. Let me show you an example here. Decimals. So this is another example. We have D dogs and we have %D cats, and then we just let the compiler know that for this one we do dogs, and for this one we will do cats. And it's gonna print 2 because dogs equals 2, and then it's gonna print 4 because cats equals 4. But this is where it gets very useful. As you can see here, we have a float number, a double number, 874.12. And what we're trying to do, we're trying to print your pay is, and this will, right here, %F will let you know that we want to put a float number inside. And gross pay is gonna go right here. But you can see that instead of just putting 0.12 as we have here, we added 4 more zeros, right? Like we don't want that. We don't want those zeros. We just want 874.12. So how do we fix that? All that you have to do, you have to specify how many numbers after the dot you want. And you can do it by just putting dot and how many numbers you want. In this case, we want 2. And then you're telling your compiler that it's going to be a float. So in this case, we printed 874.12 without all of those zeros that we had here. See the difference here? Nothing specified it just gives you this mess. If we specify that we want 0.2, it just gives us 2 numbers after the decimal point, which is really neat, especially if you're working with numbers, if you're working with some money or stuff like that. For example, right here, gross pay. So you can see 127. And then what we want to do, we're telling them no, we're telling the compiler no, that we want 2 decimals after the 2 numbers after the decimal, and we want to use a comma to separate our numbers. And what your compiler will do, instead of just printing this number as a whole, first of all, is going to round that 7 up for you, because you only want 2 decimals. We're asking only for 2 decimals, which is going to round up to 3 right here. See, we have a 2 here, but the compiler rounded up to 3. And it's going to add a comma in between 5 and 8. So it's just easier to look at, it's better to see. That's the whole point of using printf. Now, the %s will let your compiler know that it's going to be a string that's going to be printed. S stands for string. And in this case, we're passing name into here, and name is Ringo. So what's going to be printed? Your name is Ringo. You can specify how many spaces you want this variable to have. In this case, we're specifying that we want it to have 6 spaces wide. We want this number to have 6 spaces. As you can see, this is what's going to happen. It's going to have 6 spaces, and then it's going to put your number in there. So very neat. All you do, you put %sign, then how many spaces you want it to have, and then whatever data type you are passing to this location. Same thing was here. We are specifying that we want this float number, because F stands for float. We want this float number to have 6 spaces reserved for it, and we only want 2 numbers after the decimal. And in this case, 976891 is going to be printed as 9.77, because 8 is going to be rounded up to 6, going to round it up to 7. Let me see. String format. Yeah. All right, that's all I had for today. Let me stop the video.